Hi guys, so I'm going to prepare this little video here. This should get us through the rest of the chapter 7. The last part is our last few parts are basically order operations and some algebra stuff, which is probably the most important part of the whole chapter. We need to be able to be confident in this as we go forward in math. But before we get started in that, what I want to talk about is, first of all, a couple of announcements to make. We have the Math 1049 My Math Lab, of course, is finally set up. There was a few little glitches with that there, and I finally got through the person properly, and we get that all taken care of. So to access that, you go into Brightspace homepage right here, as you can see. Do not go here. Do not go here. What you have to do is actually go to your content right there, and then you go into the next page, and you'll see, all the links should be there. If you don't see these links here, you just click on My Math Lab links, and then you can go to your Math Assignment Manager right there. And what will happen there, I've already logged in and signed in. You'll have to just follow the directions, accept the policies and whatever, pay for the course, and then basically you can see that right here, the number 7, chapter 7 assignment is assigned, and it's not due until February 3rd. So that's all good to go and all set up finally. In the meantime, also our department is starting a tutorial sessions, math tutorial sessions, and it's open for the whole department, including Civil Building Technologies and ACC. And I think you're going to have two times a week where you can get extra support and extra help, and by all means take advantage of that. I think Sam's going to be tutoring it or teaching it. He's a good guy, he's very helpful. So make sure you need any extra support, you get in and see him. And that's about it for announcements. In the meantime, we should go back to our class. Okay, look at order of operations. Order of operations kind of looks like this. It says mathematicians have developed a standard order of operations for calculations that have more than one arithmetic operation. The more than one arithmetic operation means that you get multiplication and subtraction, or division and addition, those kind of things in the same equation. And we have a special order to follow. And the order goes like this. We do parentheses, fraction bars, which you won't really see those anyway, exponents, square roots. These two here are essentially the same, exponents and square roots, because the square root can be expressed as an exponent, so they're the same. Then we go multiplication and division, and going from left to right. Always go from left to right, same way as if you're reading a book. And the last step will be perform addition and subtraction, working left to right once again. Now, you may, they like this one here. I think this is probably because it's an American textbook, I'm pretty sure. They like, please excuse my dear Aunt Sally. And that stands for parentheses, exponents, multiplication, division, addition, subtraction. They use PEMDAS, or this little acronym right here, this little rhyme right here, to help you remember the order operations. We have a different one that we're more commonly used, that I most commonly use, and people that I know around here most commonly use, and we call it BEDMAS. You may have heard that before. So it's just BEDMAS. So looking at, it's the same kind of thing. The B would be here where the parentheses is. The exponents, or the E, would be right here. In this case we have division and multiplication. Notice that they are reversed in the PEMDAS, but it doesn't matter. Do division, multiplication, left to right, in the order that they appear. And then in the last part we have addition and subtraction. You're probably more familiar with the term BEDMAS anyway. So whichever method you choose to remember these, the operations always have to be done in that order. Okay, let's take a second and look at some examples of that. Looking right here, we have, I want to skip number 1 because number 1 is all multiplication. You can just multiply anyway. So I'm going to go to number 2. And number 2, you can see we have 8 plus 9 minus brackets 3 times 6. So when we start looking at these, you're not familiar with the order operations. What you really want to do first is you really want to go, oh, 8 plus 9, okay, perfect, nailed it. No, you didn't. What we have to do first is you have to do what's inside the brackets first. It's the 3 times the 6 we have to do first, not the 8 times, not the 8 plus 9. So all we do, and of course, what I do when I'm doing these, I always write down the page. And you'll see what I mean in a second. What I do, this way it's easy to see where your working is coming from, how one line leads to another line, and if you make a mistake, it's easier to find it. I don't want to see people writing things like 3 times 6, 18, take my 18. I don't want people making notes everywhere, because that's only going to be more confusing, and you don't want to get more confused. So what I want you to do is make your notes completely as you go. Oops. So maybe we'll just erase that. It'll be easier. Okay, so getting back to solving this. Since the 8 and the 9, we're not going to worry where that was right now. They'll just come right down again. So I'll write down my 8 plus my 9. The minus sign is going to be really tricky, so you have to be very careful with the minus sign. Alright? So in this case, remember I said before that the sign goes with the number? That's perfectly right. Keep doing that and you should be fine. So we'll do what's inside the brackets. The minus sign is going to stay here. And 3 times 6 is going to be 18. And going from left to right, I'm going to do this slowly so you can see what's happening. 9 plus 8 is 17. Minus 18. And you can see the answer is -1. Okay, let's try number 3. 15 times 3 minus 8 divided by 2. Well, once again, we're going to be applying the same rules as before: BEDMAS, brackets, exponents, and division, multiplication, addition, subtraction. Same as before. So, we're going to do brackets first, which is 3 times 15. 3 times 15 is going to give us 45. Minus 8 divided by 2. So, again, going from left to right, your initial thought is that you might want to do the 45 minus 8 first. But that's not what you got to do, because what happens first? It's going to be division. It's going to come next, because it's division comes before addition and subtraction. So now we're going to have 45 minus 8 divided by 2 will be 4, and that's going to equal 41. Perfect. Let's see. Maybe I'll try one more of these. Let's try to provide. If I have brackets 500 minus 250 divided by 25 plus 1 equals. So once again, do what's inside the brackets first. So this one comes first. 500 minus 250 is going to give us 250. divided by 25 plus 1 equals. So then we know that division comes before addition and subtraction. So we need to do this division piece right here. So 250 divided by 25, that's going to give us a 10. Plus 1, which equals 11. And that's the process you go through to solve that. Awesome. Let's move on a little bit. An algebraic expression. A variable is a letter or a symbol that represents an unknown number. Okay, so most commonly you're going to see like x, y, z kind of thing for these variables, and basically they just represent a number. When I start doing these, I'm going to break it in slowly. I'll show you what I mean by meaning just a number. An expression is a mathematical statement that may use numbers or variables. An algebraic expression is an expression that contains one or more variables. So these are examples down here of algebraic expressions. Right here. Awesome. So let's take a second. I want to show us the difference between the coefficient and a variable. The coefficient is actually the number that's in front of the variable. In other words, the number that's in front of the letter. So in this case, the first one, the variable is going to be the a cubed, and the coefficient is 12. Coefficient is 25, and we have b, c, d. Coefficient is 1.5, and we have an x. Coefficient is 7, we have z squared. Coefficient is 12, and we have a b squared c. So that's pretty basic. Then the coefficient is the number in front, and the variable is just the letter. Awesome. Doesn't get better than that. We should have a test just on that stuff. So we would be loving that. Okay, this is where the rubber hits the road. To evaluate an expression for some number means that we replace or substitute the number for the variable in the expression and then simplify the expression. So, some common expressions are, if a number is increased by 2.7, we add. If 9 is less than some number, we subtract. Two numbers are summed or added together, we just add. The sum of q multiplied by 5, this shows multiplication right there. And product of x and negative 9, this is the same thing, negative 9 times x. And for example, 4 times the sum of 3 different numbers. Well, there's 3 different numbers right here. Add them together times 4. And that's how it works. And the sum of two numbers, x and y and z, divided by negative 8. You can see x and y divided by negative 8 right there. Alright. Let's take a second and try some of those out. Practice 14 says some p decreased by 4.5. Basically, it's going to look like if it's decreased by 4.5, we have p minus 4.5. C multiplied by 7, and it will just be simply 7c. Sum of two numbers, a and b, that would be just a plus b. The sum of x divided by 5, we can do it two ways. We can just go x divided by 5, or we can go x over 5, that's fine. The sum of two numbers, a and b, divided by 6. So we have, what I'm going to do this way, I'm going to say sum of two numbers, a plus b. We're going to add those first, so put them in brackets, and they're divided by 6. 5 times the sum of two numbers, so I'm going to have 5 outside of x plus y in brackets, so you sum them first and then multiply by 5. The quotient number r and 3, the quotient number r and 3, and that would be the r divided by 3. 6 less than some number, we're going to have x minus 6. The sum of two numbers multiplied by 2, well, it's going to be 2 outside of m plus n, and sum of some number x and 24, so we just simply x plus 24, and that's it. So basically this all it's doing is just taking the wording and transferring it into an algebraic expression. So evaluating the algebraic expression using substitution. What that means, if I have an equation that looks like this right here, then I say x equals 2. Every occurrence where I see an x, I replace it with the value 2. So down here you can see what's happening. 4 plus x, and because x is 2, I replace the x with the value of 2. Over here I replace the x with the value of 2. Right here, and the signs all stay the same, everything else stays the same, and then basically once I have the x's replaced by 2's, I solve the equation algebraically as if I was doing the last example I talked about a few minutes ago. Let's try some of those examples. Evaluate the expression. So what happens is that I have an a of 5, b of 4, c is 1. If I look at this one here, number 1, it's going to be 4, a is 5, it's going to be 5 squared. So we're going to evaluate it, and we do the exponents first, so it's going to be 4 times 25, which equals 100. Down here we have 5 outside of the a will be replaced by 5, the b will be replaced with 4, and now we have 5 times 5 is 25, times 5 is 125, times 4, well, let's do that. Too tired, my brain's too tired to figure out that today. So I have, if you want to put in your calculator though, you can do this exact right away. You can just go 5 brackets 5 bracket squared times 4, and it'll give you the answer right away, 500. I think that's fine. The only trick here really is that right here, c to the power of 0 equals 1. So that's the only trick that's involved there. That's any number to the power of 0 is equal to 1. So I'm going to move on a little bit. If you have any questions on that, don't hesitate to send me an email, drop by, or hit the tutor sessions, or drop by and see me anytime after class or before class or whatever. Okay, this basically is some written expressions and word problems. If you see is, as, equals, or equal to, that's basically equals. If we see add, sum, plus, total, more than, increased by, that's going to be an add. If we see subtract, difference, minus, remainder, less than, decreased by, it's always going to be subtraction. These are key words that actually help you determine which operation is happening. So over here, multiply product times of its multiplication, and addition would be, division would be divide, quotient, split, per, and it's all division. That's how you recognize it. So if you're doing a word problem, you look for these key phrases or these key words to know what operation you're going to be doing in the word problem. And we know we all love word problems. Awesome. So write this as an expression. Robert had 2 fewer cavities than I had. So Robert is equal to me minus 2. My cavities minus 2 would be the cavities that he has. He has 2 fewer cavities than me. I doubled my income after I finished the certificate program. So your income becomes 2 times your income before it's through the program. The initial income. I split, the stipend increased her income by $500, so basically it's going to be income equals I plus 500, and he lost 12 pounds this month. It's going to be x minus 12, and so on. Next one, solving equations. This is probably the most important part of math. You have to be able to solve this in an equation. So basically, solve an equation to get a variable by itself on one side, with the equal sign. That's basically, say it again, it's kind of disjointed. To solve an equation, you have to get a variable by itself on one side of the equal sign. Use inverse operations to do this. I'll do these slowly so you'll see what happens, but basically it goes like this. Addition is the inverse of subtraction, multiplication is the inverse of division, and so on. So, this will take a second. Hop down here. Try to find something. I hope you can find it. Make this a little bit easier if I can find it. Just give me 1 second. Okay, so I actually didn't find that piece I was looking for, but let's just get ready to solve this stuff anyway. So, looking at solving the equation right here of x plus 1.5, in order to solve that, we need to get x by itself. Okay, so to get x by itself, okay, that's what I was looking for. I'll just try it again. It makes more sense when you see this. What you see here is a balance, and doing algebra is a lot like this balance piece here. What I mean by that is that you have two sides here. You have this side over here, and you have this side over here. So if I were to put a weight on this side, or something I want to measure, put it over here, it's going to bring this arm down. So in order to keep it balanced, I got to put the same size weight over here. So the same force is acting down, and the thing remains balanced. Now, an algebraic expression is exactly the same. If we do something on one side, we do the exact same thing on the other side, except in the piece here is the equal part. So if I take one away, I take one away. If I add one over here. So you can see what's going to happen as we start doing these algebra pieces. Alright, so back here. So to get the x by itself, I need to get rid of 1.5. To do that, I just subtract. I subtract 1.5 here, but I also have to subtract 1.5 over here. The 1.5 on this side goes away to 0, and then you see how the x is left by itself. And we have 0.5, negative 5.2 minus 1.5 gives the total here. Again, we get rid of these by doing the opposite operation. Look at this equation down here. We have x minus 7, sorry, z minus 7. In order to get rid of that 7, because it's a minus sign, we got to add 7 here. But to keep things balanced and even, we got to add to both sides. So we add 7 over here. Then negative 7 plus 7 disappears, and my z is equal to 5 plus 7. See? No problem. Here we see we have multiplication, and the opposite or inverse of multiplication is division. So to get the a by itself this time, you have to divide by the coefficient of 5. 5a over 5 equals 36. And if I divide by 5 on this side, I also got to divide by 5 on that side. These 5s will go away, they'll cancel each other out. And I'm left with 36 divided by 5, which is 7.2. Okay, and then for example, the next one we have solve the equation. So if I want to get the y by itself, I can multiply both sides by 2. Multiplying by 2 on both sides, you see what happens? This side, 2's will cancel. And I have 2 times 3.8 on the other side. And that's going to give us 7.6. Alright. Let's look at some of these examples. I'll work some of these out and see how it goes. I'll just pick some at random. I'm not going to do all of them. But I'll pick some now and we'll do some more when we get back in class next week. Let's look at number 2. 2 says we have I'm going to try a little trick first of all, and show you how I was usually explained these concepts as well. So what I'm going to do, I'm going to take this here and get a square. I'm going to put my square right here. And I'm going to have square minus 13 equals 42. Now most people would have a look at this and they'd say, okay, there's an empty box and we need whatever the empty box is, minus 13 gives us 42. So it's easier to visualize, at least for me it was in the very beginning, that like I had an empty box, I'm going to put some number in here and life is good. But people always say like they lose the math ability, totally hate it when the letters get involved. Well, the letter looks like this. All what's happening here is Z over here. There's no square box on their keyboard. So typing up squares, it's not going to happen. So what are we going to do? This goes out here. The Z now becomes in here. And we can get rid of the box now. Go away. And now we have the algebraic expression. So you see that the Z basically is just the box, an empty space. It's just a thing that holds its position and actually just is the same as, actually it is a number. To determine the number, we have to actually apply the algebraic operations. So now what we do, you see a negative 13 right here. which means we're going to have Z minus 13 plus 13, and if I put plus 13 on the left side, I gotta put plus 13 on the right side. On this side, they will cancel out, go to 0. And on the right hand side, we're going to have Z 42 equals 42 plus 13 is going to be 55. Let's do number 8. 8, as we can see, you have 12c equals 60. We need to get the c by itself, so in order to do that, we have to divide by the coefficient number. So I have 12c divided by 12, that equals 60 divided by 12. And you can now see that these 12s here cancel out. And I have c is going to be equal to 5. Awesome. So try some of those. If you have any problems with those, make sure you get some help. Make sure you try lots of those. This is basically, you need to know this for any math you're doing, math, physics, chemistry, anything. This is a very important skill you have to develop. We'll probably spend a little more time on that in class, but we want you to practice it yourself at home. And if you have any questions, please get help on this part right away. All right. Just a few more things to finish up. We have algebraic writing equations from word problems. Algebraic equation is an equation that contains more than one variable. So this should bring into the example here. For example, if patient's temperature is decreased by 2 degrees, it will be 99.4 degrees. What will the patient's temperature be now? And basically taking this phrasing, this is the hard part of doing a word problem, turning it into an expression that goes like this. That's how we do it. So temperature decreased by 2 equals 99.4. So the hardest part of doing a word problem most of the times is taking it from this point right here and transferring it into a number piece. So let's have a look at some of these examples now and see if we can transfer them a little bit. Sharon wants to donate 120 nursing books to the library. The nursing collection has 1,357 books stored on the library shelves. How many books will be in the collection after Sharon donates? So basically it's going to be 123 plus 1357 equals 3x7. Add them together. Patient's pulse decreased by 8 minutes, 8 beats. It will be 78 beats per minute. How many beats? I can't read this. Oh, I'm so tired. A patient's pulse decreases by 8 beats. It will be 78 beats per minute. How many beats a minute is his pulse before the decrease? Wow, got it out. So if it decreases by 8 beats per minute, and will be 78 beats. This piece here means it's going to be equal to 78 beats. Right, if it decreased by 8, we're going to have something minus 8. So it's going to be x minus 8 for that equation. And you can solve that yourself now. It's not a big deal. I'm just going to run through a couple of these, see what happens. If you double the cost of a dietitian's apron and then add $2, you will get the cost of a tailored dietitian's jacket. And the dietitian's apron costs $16.50. How much will the dietitian's tailored jacket cost? So let's break this down. If you double the cost of the dietitian's apron, which means dietitian's apron cost right here, so it's going to be 2 times that. Oops. 2 times that, and then you add $2 to double the cost, and you add $2 to get the dietitian's jacket. So it's going to look like this. It's going to be 2 times 16.50, which is 2 times the dietitian's jacket plus $2. So this person here has 7 more patients than Juan. If he has 18 patients, how many does Juan have? So Din has 7 more patients than Juan. So Din has Juan's patients. Hang on, I'm doing this backwards, my bad. So Din has 7 more than Juan. Din has 18. So how many does Juan have? So Din has 18 and has 7 more than Juan, so it's going to be 18 minus 7 equals Juan's patients. So Juan has 11 patients. So number 6, divide the number by 5. It's going to be x divided by 5. Then add negative 8 plus negative 8. That equals 3. I need you to solve that. Alright, so that's fine. That's all good. We'll end it up there for now. We'll do a little review of this again next week. Make sure everyone's up to speed on it. Make sure you review the video a couple times if you have any questions or problems. And there will be a test coming up soon, so we get ready for that as well. In the meantime, have a great weekend, and I will talk to you guys really soon. Bye-bye.